So next topic is that master theorem. Okay. Suppose we have an shape of the equation. If we have these types of the shape in the question, then if we do the recursion tree method, what I did till now, then it will be very difficult to calculate. You have to draw the trees, okay, and everything you have to do, and then you have to calculate it. I do not want to do this. I want to make it more simpler. How can I do this? So first you have to identify this equation, this shape of the equation. Without this shape of the equation, it is not possible to apply the master theorem. And the second thing, you have to check that whether the a variable is greater than or equals to 1 and the b is greater than 1. If you have checked this, then just identify that in which case it is falling. So in order to do that, which case it is falling, I am taking first of all the case 1. I am taking as the case 1. In the case 1, if f of n equals to order of n to the power log b a minus epsilon for some epsilon greater than 0, then t of n equals to theta of n to the power log base b a. This is the first case I have to identify. Now it is going to be very difficult if you understand like that the case 1 is saying if the f of n means this f of n equals to order of n to the power log base b a minus epsilon, where the epsilon is greater than 0, then we can identify very easily the time complexity is theta of n to the power log base b a. This must be. So before that, you have to identify first one, this one, if the equation is in this shape. The second one, you have to identify this function if fall into this condition. Now we know that what is the order of something. We know about the what is big O. We know what is the theta. We know what is the omega. The big O means this one should be Okay, just give me some time. Means this one should be greater than this function. What is this function? Greater than this function. Yes. So this one should be greater than this function. Greater than means it is the faster than this function. It should be faster, much faster. Thus than this function. Suppose we know that the n log n log n. So the n log n is very faster than the n. So here this condition is right. So we'll understand it with an example. So let's see with an example. So here is our example. Suppose this is given Tn equals to 90 n divided by 3 plus n. First of all, check this, that if this equation fall, first of all check that if this equation fall with this. So Tn equals to 9. Can I say that the 9 is like a, can I say that the b is like a 3, because n by b equals to n by 3. So b equals to 1 by b equals to 1 by 3. So b equals to 3. Here f of n equals to n. So the shape is matching, and I can identify very easily that a equals to 9 and b equals to 3 and f of n equals to what? N. We have got it. The second thing we have to understand that what is the f of n? F of n means n. So n equals to order of n log n. So first I have to calculate what is. So sorry. So first I have to calculate that what is n to the power log of base b, and this is a. So what is n here? N to the power log of, I have already identified what is b. B is nothing but the 3, and what is a is 9. Sorry, this is 3. So equals to what? So it is very easy to determine, because log base 3 9. How can I identify? You can say that 3 to the power 2 equals to 9. So log base 3 9 equals to 2. This one should be here and this one should be here. So this is actually we know. So can we say that into the power 2 it is right. So n square. Now n square. So what was actually our f of n? Order of this. So f of n equals to this one. See this one. F of n equals to order of n log n. What is the value? This is n square minus epsilon. We can very easily write it. Now epsilon. What about the epsilon? We have already seen that the epsilon should be greater than 0. Okay. Just take that the epsilon equals to 1, which is greater than 0, right? So can we say that the order of n to the power 2 minus 1 equals to order of n to the power 1? We can say order of n means we can say it is order of n. So here we have to check that if this condition is satisfying or not, this condition. So what is f of n here? What is f of n here? F of n is nothing but the f of n is nothing but the n. Okay, so let's write the n. N equals to order of n, isn't it? N is so this one should be greater than equals to this one. So the n is greater than equals to n. This condition satisfy because the n this one should be greater than in order to speedness. So it is the fastest than this n. So you can say that this condition is satisfying. So this condition is satisfying. So if this condition is satisfying, then I can very easily say that this equation I can also apply. So what is actually our T of n? So what is our T on n means what is our time complexity? Time complexity is order of n to the power, so theta, this is theta, okay, theta into the power log of 9 equals to theta n to the power 2. This one should be our equation. This one should be our time complexity. Now you can say very easily that how easy it is to calculate our time complexity. Okay. So if I do it with the recursion tree like we did earlier, then it will be very difficult. So how easily, with a very less amount of time, I can very easily calculate the time complexity of this equation. Right. Now here also has case 2, because every time with the shape of this equation, every time it is not possible that this will fall into this case. This case means f of n always will be big O of this equation. It will not fall like that. So case 2 is here for that. What is case 2? The case 2 is saying if f of n equals to theta of n to the power log of b of a. First we have to check first case. Then if the first case is not falling, then we can check about the case 2. The case 2 is saying that if f of n equals to theta of the first one was the big O, it is the theta. So n to the power log of base b a. Then the time complexity will be little different. It will be theta of n to the power log of b a and log of n. This will be actually our time complexity at this moment. Okay. So better we can understand it with an example. So let's say about the example like t of n equals to, okay, so t of n equals to t to n by 3 plus 1. Now you can see here what is a, identify what is a 1, identify what is b 3 by 2, yes 3 by 2. So just see about the function. So f of n equals to say about the function. So about the function f of n equals to theta of n log b a. So theta of n to the power log b a. This one I have to satisfy. So before that, calculate log of b of a equals to n to the power log of what is b? 3 by 2. What is a? Is 1. Okay, anything is 1, anything of the base 1, anything of the logarithm, if the base, anything can happen. If it is 1, then we can say it is our 0, right? How? Because you can imagine that 3 by 2 to the power 0, then only we can say it is 1. So isn't it the log of 1 of base 3 by 2, we can say it is 0. So n to the power 0 equals to 1. Now f of n equals to 1. So what was actually our f of n? What was our equation? The f of n equals to 1 here. So it will be better to understand that it is the theta of was, okay. So theta of this, so theta of this, so it is theta of 1. So let me write it in better possible way. Equals to theta of 1. So f of n equals to 1 equals to theta of 1. We can say that what is theta? Theta, we know that if it is lower bounded and upper bounded both by an equation. So it is 1. We can satisfy very easily. We can say very easily that this is satisfying. Okay. So the case 2 is satisfying. We can say very easily. Case 2 satisfying. How it is satisfying? Because the case 2 is saying that if f of n equals to theta of n to the power log of n. So yes, obviously it is, because 1 equals to theta, because we know that should be less than equals to or greater than equals to. Anything can happen in the case of theta. So it is applying perfectly, no problem. Now calculate the time complexity. Then what will be the time complexity in this case? The time complexity will be theta of n to the power log b a and log n. So Tn equals to what will be? Theta of n to the power log b a. So what is the log b a? We have already identified the log b a equals to 0. And what is about the log n? This is the log n. N to the power 0 equals to 1. So theta of log n. So what is our final conclusion? That the time complexity of this equation must be theta of log n. So how easy it is, right, for the case 2. Now the case 3 also may happen. What about the case 3? What about the case 3? The case 3 is saying that if Tn equals to a t n by b plus f of n, the equation we have where a greater than equals to 1 and b greater than 1, then if f of n equals to omega of n to the power log of base b a plus epsilon, you can see very easily that what I am saying here, plus epsilon, okay. Plus epsilon, where the epsilon greater than 0, where epsilon greater than 0, and the second condition also apply. Second condition also meet, that is a f of n by b less than equals to c into f of n, where c greater than 1 for all n. Okay, then we can say that t of n equals to theta of f of n. Okay, so we will understand it better possible way with an example. So let's start with an example, because it is the better thinking to start with an example without marking everything. So let's take an example that Tn equals to 3t n by 4 plus n log n. Okay, so first understand that what is a equals to 3 and b equals to 4. Now what about the f of n? So the f of n equals to, what we can say from here, that f of n equals to omega of n to the power log of, what is b here? 4. What is a here? 3 plus epsilon. So first calculate this one, log of 4 3. So after calculation we can get this is 0.793. Plus epsilon. Okay, so we have two conditions, so I am just applying the first condition here, because if these two conditions if meet, then only I can say if these two conditions, the first condition is this one and the second condition is this one. If two conditions meet, then we can apply it. The first condition just I am checking. Sorry, this one first condition, right? So first condition I am checking here. F of equals to theta of n, where theta is greater than 0. Okay, let's see. So just for sake of example, let epsilon equals to 2. Let's say the epsilon equals to 2. So what will be our omega? 0.793 plus, sorry, epsilon equals to 0.2. Very small value I am taking 0.2, because one if I say 2, then it will be beyond of 1. Okay, so I do not want it. So that's all are n to the power. Okay, that's all are n to the power. So equals to epsilon n to the power. This calculations comes nearly 0.993 equals to epsilon n to the power 1, because 0.993 is nearly is 1. Epsilon is n, I am taking it. Now this is actually f of n. Okay. Now what was actually f of n? Where is f of n? It is our f of n, right? It is our f of n. F of n is n log n. F of n is n log. So it is actually our n log n. So f of n is n log n equals to omega of n. So you know definition of the omega, how the omega work. Omega means f of n should be greater than this value. Is it possible here? Here I can say that the n log n is lower bounded n log n is lower bounded by n. I can very easily say it, because n log n is faster than the n, so the n log n is lower bounded by n. So from this conclusion I can say that first condition is satisfying very easily. Now what about the second condition? What was our second condition? The second condition was a of f less than c of f of n. So let's see, is it working or not? So our second condition were a f of n by b less than equals to c dot f of n, where c greater than 1. A is our 3, f of n by b. What is b here? B is 4 less than equals to c dot, what is f of n? N log n. So just calculate the f of n by 4. This will be n by 4 log of n by 4 less than equals to c dot n log n. Okay, so just take it out, the 3 by 4. Other than this we can get this one, c dot n log n. For sake of let c equals to 3 by 4. For sake of easiness I am taking c equals to n by 4. Now 3 by 4 n log n by 4 less than equals to 3 by 4 n log n. Okay, is it satisfying? Yes, it is satisfying, because if we ignore these two, then we can see that n by 4 obviously increasing very low than this n log n. So it is also satisfying. So one condition and second condition is satisfying. So can you apply the second one, that t of n equals to theta of f of n. So t of n equals to theta of, what is our f of n? N log n. This is actually our answer of this question. So after satisfying conditions, we can very easily apply these formulas. Good. I am stopping here now.